We are going on with Mathematics Paper 1 of November 2021. Question 4. Consider the linear pattern of 5, 7, 9, and so forth. 4.1. Determine T51. So what we want to do is find the value of the 51st term in this number pattern. And the formula for a linear number pattern is Tn is equals to A plus n minus 1 d. This is available on the formula sheet, where A is the first term in the pattern and d the constant difference between the terms. So all I need to do is substitute A with 5 and d with 2. Now I can find the value of the 51st term by replacing n with 51. So T51 is equals to 5 plus 51 minus n times 2. And that is equal to 105. 4.2. Calculate the sum of the first 51 terms. First, we find the Sn formula on the formula sheet for a linear pattern. Then I substitute n with 51, a with 5 because that's the first term, and d with 2 because that's the difference between terms. And when I simplify with my calculator, I find that the sum of the first 51 terms is equal to 2,805. 4.3. Write down the expansion of the sigma notation and show only the first 3 terms and the last term of the expansion. So in order to expand the sigma notation, I would start by substituting n with the first term, which is equal to 1. So the bottom number in our sigma notation is the number where we need to start our substitution. So the first term would be 2 times 1 plus 3. The second term would be 2 times 2 plus 3. The third term, 2 times 3 plus 3. And the last term, 2 times 5,000 plus 3. And the 5,000 is the top number from the sigma notation. And when I simplify, I have 5 plus 7 plus 9 as my first 3 terms. And I continue with this pattern up until my last term of 10,003. 4.4. Hence or otherwise, calculate these two sigma expressions added together. All working details must be shown. What I would do is simplify every sigma expression by itself. So let's start with the first sigma expression. I'll start my substitution with 1 to find the first term, and then I'll only find the first 3 terms. That'll help me to establish that this expression is linear, meaning there is a constant difference between terms, meaning that I can use the Sn formula for an arithmetic pattern. Also, what I need to establish is the number of terms in this pattern. And the number of terms in this pattern is the top number of the sigma notation minus the bottom number plus 1. So it's 5,000 minus 1 plus 1. So there are 5,000 terms in this series. So if I use the Sn formula for an arithmetic series, I substitute n with 5,000, a with 5, and d with 2. And when I simplify on my calculator, I find that the first sigma notation would be equal to 25,020,000. And I'll do the same for the second sigma notation. So first I'll expand to find the first 3 terms, which is -3, -5, and -7. Then I find the number of terms by taking the top number in the notation minus the bottom number plus 1. So there are 4,999 terms in this series. I also can see that there's a constant difference of -2 between terms. So that means I can use the formula for the sum of an arithmetic series. And when I substitute n with 4,999, a with -3, and d with -2. And when I simplify on my calculator, I find that this sum is -24,999,999. Therefore, to calculate the sum of these two sigma notations, I simply need to add these two values with each other. And that answer is 20,001.